frame length in standard Ethernet, minimum and maximum. So minimum frame length is 512 bits or 64 bytes, and maximum frame length is 1518 bytes. Okay. From this destination address, source address, length PDU, data and padding in CRC, it comes under data link layer. So now header and trailer are the parts of this length. This is our header and this is a trailer. Okay, total length, sum of this total length is, okay, here 12, 2 and 4, 18 bytes. Minimum length data from upper layer. If we want to get the minimum length of the data, total is 64 and minus this 18 bytes. So we have 46 bytes. That is our minimum data length. And upper layer. If upper layer packet is less than 46, then padding is added to make the difference. Then likewise for maximum length also. Standard defines the max length of the frame without preamble and SFD field. We are including only from the destination address to CRC. Here 1518 minus 18 bytes. So 1500 is our maximum length. Okay, this is the length of this data padding. Addressing, we have three types of addressing. One is unicast, multicast and broadcast. The source address is always unicast if it comes from only one station, that is one to one relationship, one station and one recipient. Here we are having multicast address, that is this defines a group of addresses and relationship between the sender and receiver. This relationship is one to many, that is one station and more number of recipients. Broadcast address, all bits are once recipients, all stations of LAN. So all bits are once recipients and all stations of LAN. That is, if we have consecutive ones, 48 ones, that is the destination address. Okay. For example, here we are having 06, 01, 02, 01, 2C and 4B. This is our Ethernet address. It is in hexadecimal notation. Okay. Now, whether it is unicast or multicast or broadcast, we have to find this. So, convert this 6 into binary, that is this hexadecimal into binary. If we convert this, we will get 0 at the end. So, if we get 0 for this least significant bit of this first byte in the address, then it is called as unicast. For example, if we have 07, when we convert into binary, we will have the remainder 1. So, it is the multicast address. And for broadcast, this is not the address. For example, if it comes like this, F, then it is called as broadcast address. All the digits are same and all the digits are F. See, this is the least significant bit. Converting this, we will get 1 as last digit. So, our least significant bit is 1, so it is multicast. So, here we use CSMA CD access method for standard Ethernet. It uses one persistent CSMA CD. Okay, CSMA is used to reduce the collision. This is called as carrier division multiple access and carrier sense multiple access. CDMA is carrier division multiple access. The CSMA is carrier sense multiple access with collision detection. Okay, it has the augmented algorithm to handle the collision. Minimum frame size. Minimum frame size is nothing but the so before sending last bit of frame, since sending station must detect a collision. Okay. If a collision occurs, then the transmission will get delayed. So our formula is, this is the frame transmission time, that is data transmission time. Data transmission time is greater than or equal to twice the propagation delay time. This TP is propagation delay. Okay. If we want to calculate minimum frame size, then it is equal to bandwidth into TFR. That is this time, this frame transmission or data transmission time. Okay. This is our energy level. If it has three values, if it comes 0, normal and abnormal. Normal means station successfully sends the frame. Abnormal means collision occurred and the energy level is twice the normal level. Okay, throughput. Here we are using one persistent method. For one persistent method, maximum throughput percentage is 50%. For non-persistent method, the maximum throughput is 90%. So this is another formula to calculate slot time. Slot time is equal to round trip time plus time required to send jamming sequence. Once the collision is occurred, then we will stop sending the frames. That time jamming signal is used and it is stopped. That is done by CSMA or Curry-Essence multiple access. Then once the system becomes idle, then only it will send the data. Okay. A traditional slot time, it is defined as 10 Mbps per second, and for Ethernet 51.2 microseconds. So slot time and collision. Before sending the packet, the signal travels throughout the network and reaches the end. So before sending the data, it will check whether the collision will occur or not. Then sender aborts the sending frame and send the jam sequence to inform other stations about collision. Okay. Then slot time and maximum network length. Signal propagates at 2 into 10 power 8 meters per second. Okay, maximum length is equal to propagation speed, that is this speed, signal propagating speed, into slot time by 2. Here we are having a slot time 51.2 microseconds. So slot time by 2. Microseconds can be written as 51.2 into 10 power minus 6. That is 5120 meters. Okay, we must consider the delay time in repeater. So our maximum length is 2500 meter. Solving this one, 2500 meter by 5120 meter, then we will find that 48% is reduced. Okay. Physical layer, encoding and decoding. So digital signaling or baseband is, that is the speed is 10 megabits per second. Okay. From sender to receiver, physical layer did this conversion. Convert to digital signal using Manchester encoding. Here it uses the technique Manchester encoding. It is self-synchronized.